Hello, this is Max, and today I'll show you my solution to the tile problem. In this problem, there are two different color tiles in a bag. Two of the tiles are red and two of them are blue. If you take out two same color tiles, you win. If you take out two different color tiles, you lose. So as of the start, you have a 1 in 3 chance of winning. This 1 in 3 chance is depicted by the formula here. With this formula, we can calculate out for any chance that we want by setting the probability of winning to whatever we want. Here we'll set the probability to 1/2. And then we'll solve for 1/2. After a bit of solving, we run into a problem. First of all, we have this equation right here. And at first, it might look like you have two variables in a system of equations, and you'll have to guess and check integer values in order to find a solution. Well, you can constrain the problem. But first, you want to simplify it using the quadratic formula. We can rewrite the equation into 0 equals AR squared plus BR plus C form, and then we can use the quadratic formula to solve it. If we simplify, we get this equation. We can use this to our advantage. We know that the square root of 8b plus 1 has to be an odd number, because only if it's an odd number will it end up ending with a 0.5, making this 0.5 0 or 1. With that information, we also can figure out that b has to be a whole number, and the only way to get b to be a whole number is to have the square root of 8b plus 1 equal a perfect square, because then an odd perfect square, because then the perfect square will be odd. So our first condition is met, and we'll have a number without a decimal equaling 8b plus 1. So we now know that we now have a conjecture that any odd number squared minus 1 over 8 equals our b, which the only thing we need to prove this conjecture is to make sure that this here equals a whole number no matter what value you choose. This was something quite difficult for myself to prove, and I did it by first setting n equal to 2m plus 1 and then substituting it into the equation. If we simplify it, we get 1/2 m squared plus 1/2 m equals k. Now m can be any integer that's positive or 0, because we will create an odd integer that is positive out of the m input. So if m is an odd number, then m squared will also be an odd number. So then this will be odd, and this will be odd as well. So with these two m's being odd, they'll both end in something 0.5. So if we have two 0.5s added together, we'll get a 1. So it's going to be two values that both end in 0.5 added together to have another value that has no decimal behind it. If it's even, then the dividing by 2 will result in a whole number, which will also make k a whole number. So for any integer m, where m is greater than or equal to 0, k is a whole number. So with this, we can write our b as n squared minus 1 over 8, and our r as n squared minus 1 over 8 plus 0.5 plus or minus n over 2. This formula is derived by plugging in our n squared minus 1 over 8 into r equals b plus 0.5 plus or minus the square root of 8b plus 1 over negative 2. I hope you found this video helpful, and thank you for watching.